In 2022, astronomers working with the Australian Murchison Wide Field Array (MWA) radio telescope detected a signal from space that defied conventional explanations. This signal, bizarre in its nature, repeated at regular intervals of 22 minutes. Intriguingly, when astronomers delved into historical data, they discovered that this exact signal had been recurring for over 30 years, maintaining its periodicity without any noticeable change. This enduring anomaly has puzzled scientists and driven them to investigate its origins, leading to numerous theories but no consensus. The signal's consistency in repetition raises significant questions. According to scientific calculations, its source should be located within the GUM constellation. However, despite extensive research and theoretical proposals, no definitive explanation has emerged. The peculiar nature of the signal, with its 22-minute repeating cycle, sets it apart from other known astronomical phenomena and poses a challenge to our understanding of cosmic signals. Astronomers have long been intrigued by repeating signals from space. The first such signal was discovered in 1967 using the Interplanetary Cation Array, which detected a signal at a frequency of approximately 110 MHz repeating nearly every second and a half. Initially, scientists speculated that this could be a communication from an extraterrestrial civilization, dubbing it LGM-1, short for Little Green Men. However, subsequent research revealed that these repeating signals were not of alien origin but rather a natural phenomenon. Over time, astronomers identified several repeating signals from various distances, leading to the realization that such signals are not unusual but rather a natural occurrence. These signals are produced by pulsars, which are small neutron stars with extremely strong magnetic fields. Pulsars emit electromagnetic waves from their poles and rotate rapidly, emitting radio waves like a cosmic lighthouse. Despite the regular pulsations, most known pulsars are located within our galaxy, with about 3,000 identified to date, a fraction of the total number of stars in the Milky Way. Pulsars are characterized by their rapid rotation and intense magnetic fields, which can be billions of times stronger than Earth's magnetic field. As they spin, they emit beams of electromagnetic radiation, including radio waves that sweep across space. When these beams align with Earth, they are detected as pulsating signals. However, the signal detected in 2022, repeating every 22 minutes, is much less frequent than typical pulsar signals, which can repeat every few milliseconds to a few seconds. One possibility is that the signal could originate from a very slow pulsar, but such a scenario is unlikely. Pulsars generally lose their rotational speed over time, eventually leading to the cessation of their radio emissions. The signal in question, emanating from an object designated as GPM J183910, appears every 22 minutes with an unusual and irregular pattern. The intervals between signals are consistently 22 minutes, with the signal duration varying between 30 seconds and 5 minutes, which deviates significantly from regular pulsar signals. This irregularity has led scientists to compare the signal with fast radio bursts, FRBs, which are short-lived, high-energy pulses lasting only a few milliseconds. The first FRB was recorded in 2007 by the University of West Virginia using the Parkes Radio Telescope. It originated from the Small Magellanic Cloud, 200,000 light-years away, and was speculated to be associated with a supernova explosion. Subsequent FRBs, including a repeating FRB detected in 2018, displayed similar high-energy characteristics but differed in their repetition patterns. The 2018 repeating FRB, originating from 457 light-years away, emitted bursts every 16 days for 4 days, with 1 or 2 bursts per hour, before vanishing for 12 days. This periodic behavior resembles the 22-minute signal but only in its periodicity. Most FRBs are solitary and not associated with regular patterns, making the repetitive nature of the 22-minute signal particularly intriguing. Theories about the origin of these signals have evolved, with some researchers suggesting that FRBs could be the result of catastrophic cosmic events such as the collision of neutron stars or supernova explosions. However, such events are not expected to produce repeating signals at fixed intervals. An alternative hypothesis proposes that the signals could be generated by magnetars, a type of neutron star with an extremely powerful magnetic field far stronger than that of typical pulsars. Robert Duncan and Christopher Thompson proposed the magnetar model in 1992 to explain repeating gamma-ray bursts, which are among the brightest electromagnetic events in the universe. Magnetars, due to their intense magnetic fields, emit bursts of energy irregularly, but their long-term periodicity does not align with the 22-minute signal observed. Despite this, scientists have considered the possibility that the 22-minute signal could be related to a magnetar's activity. In 2020, astronomers traced a repeating signal back to a magnetar located near the center of our galaxy, 30,000 light-years away. The Dominion Radio Astrophysical Observatory recorded 2 flashes within 28.9 milliseconds of each other, but these flashes did not recur. When astronomers observed the area associated with the 22-minute signal, they detected a compact object resembling a neutron star, potentially a magnetar. However, the lack of observable slowdowns or irregularities in its rotation over 30 years of observation remains a challenge to this hypothesis. Further complicating the mystery, some researchers have noted similarities between the 22-minute signal and FRBs detected in other studies. For instance, in 2019, the CHIME radio telescope recorded an unusually long FRB lasting 3 seconds, with periodic peaks resembling a heartbeat rhythm. This FRB was located in a nebula within the Milky Way, 9,000 light-years away, and was thought to be a magnetar with a powerful magnetic field. However, like other theories, this explanation fails to fully account for the signal's slow repetition cycle. Professor Tomonori Totani and graduate student Yuya Suzuki from the University of Tokyo conducted research into the origins of FRB signals and discovered that repeating FRB signals might share similarities with seismic activities on Earth, such as earthquakes. They found that FRBs exhibited statistical similarities to earthquakes rather than solar flares, suggesting that neutron stars, especially magnetars, might experience starquakes due to their rapid rotation and intense gravitational fields. These starquakes could potentially generate FRB signals, though this theory does not fully explain the regular periodicity of the 22-minute signal. One hypothesis posits that the 22-minute signal might be related to a unique physical mechanism involving coherent radiation generation. In this theory, electromagnetic radiation interacts with a quantum system with 2 energy levels, causing it to emit periodic signals. This coherent radiation could produce powerful signals with regular intervals. However, scientists remain skeptical that such a system could exist around an active object like a magnetar, where turbulence and scattering would disrupt coherence. Another possibility is that the signal could be generated by an asteroid orbiting around the magnetar, triggering energy bursts at regular intervals. However, an asteroid with a 22-minute orbital period would likely be too close to the magnetar and would be torn apart by its intense gravitational forces. This theory, while intriguing, faces significant challenges due to the extreme conditions near a magnetar. In recent years, a large team of American astronomers and physicists has sought to address the mystery of FRBs using advanced statistical tools.
Oldest black hole ever observed,
they discovered
dating
that
from the
many
very dawn of
FRBs
the
could
universe
potentially
more than
repeat,
13
but
billion
only a
years
few are
ago.
observed, leading to the
In this
conclusion
video,
that our
we will
understanding
explore
of
this
these
amazing
signals is
discovery,
incomplete.
which is located in the
This has
galaxy
led some
GNZ
scientists
11,
to
the
consider
most
the
distant
possibility
and
of
oldest
artificial
galaxy
origins for
known.
these signals.
This discovery is
AVI
important and exciting
Laban
because
Manasvi
it
from the
challenges
Harvard
our current
Smithsonian
understanding
Center
of
proposed
black hole
that the
formation
repeating
and growth,
22-minute
and it
signal
could
could
shed
be from
light on the early
extraterrestrial radio
universe and the
transmitters powered
reionization
by
era.
stellar energy.
We will answer the
According to
following
this theory,
questions.
advanced
How did James Webb
civilizations
detect
might
the
use
black
such
hole?
transmitters to power
What does this
spacecraft or
discovery
probes
tell us
traveling
about the
through
early
interstellar
universe
space
and the
at near light
reionization
speeds.
era?
If
What
this
are the
were the case,
implications
the
and the
transmitter
future
would need to be
prospects
an
of this
enormous
discovery?
structure, potentially twice the
So,
diameter
if you
of
are
Earth,
curious
or an
and
artificial
fascinated by the
stellar-scale
mysteries of the
structure.
cosmos, then
This
stay tuned
hypothesis
and watch
envisions
this
a network
video
of
till
these
the
emitters
end.
used for communication
How did
and energy production.
JWST detect the black hole?
While this theory is
The black
captivating,
hole
no
and the
Dyson
galaxy
spheres,
that hosted are very
hypothetical
far away
structures
from us,
designed to
more
capture
than
stellar
13
energy,
billion
have
light
been
years
observed
away.
near the magnetar.
This means that the light
Additionally,
we see
the
from them
magnetar's
today was
magnetic
emitted more
field
than
would likely
13 billion
disrupt
years
any such
ago, when the
structures.
universe was only 400
Nonetheless,
million
the
years old.
possibility of an artificial
To
signal
put this in
remains a topic of
perspective,
debate,
the
with
universe
some
as we know it
scientists
from current
speculating that we
theories
might
is
be
now
detecting
about
signals from an
13.8
advanced
billion years old.
extraterrestrial civilization.
So, we are seeing the black
Historically,
hole
there
and the
have been other
galaxy as
instances
they were
where
when the
signals from
universe was
space
only
were initially
3%
thought
of
to
its
be of
current age.
extraterrestrial origin.
This also means
One
that the light
notable
we see
example
from
is
them
the
has been
WOW
stretched by
signal
the
detected
expansion
in
of the
August
universe,
1977
shifting it
by
from the
Dr.
visible to
Jerry
the
Ehrman
infrared
using the
spectrum.
Big Ear radio telescope.
This is called the redshift,
This
a
signal
measure of how
exhibited
far and
characteristics
how old the
consistent
objects
with
are.
interstellar communication
The
and
higher
was
the
detected at a
redshift, the
frequency of
farther and the older the objects
1420
are.
MHz, a
The
wavelength
black hole
associated
and the
with
galaxy
hydrogen,
have a
a
very
prime
high
candidate for
redshift of
space communication.
11.1, the highest ever
Despite the
measured for
initial
any
excitement,
object in the
the WOW
universe.
signal never
But
repeated,
how did
and
James Webb
subsequent
manage to see such a
investigation
distant and
attributed it
faint
to
object?
terrestrial interference.
The answer is by
In
using the
2003,
gravitational lensing
the SETI
effect.
Search for
This
Extraterrestrial
phenomenon
Intelligence
occurs when the light
project
from a
recorded
distant
new
object
candidate
is bent
signal at
and
a frequency
amplified by
of
the
around
gravity of a massive object in the
1420
foreground,
MHz,
such as a
similar
galaxy
to the
cluster.
WOW signal.
This creates
This
a
new
distorted
signal
and
was
magnified
detected
image
3
of the
times,
background
but its
object,
source was
like a
traced to a
cosmic
region between
magnifying
the
glass.
Pisces and Aries constellations,
Webb used the
where no known
gravitational
stars
lensing
or
effect of a
planetary
galaxy
systems were
cluster
located.
called MAX
Due to its weak strength
J11495
and short
plus
duration, the signal
2223,
was
located
inconclusive
about
and
5
did not
billion
provide
light
further
years away
insight
from
into
us,
potential
to boost the signal of
extraterrestrial
the black
communication.
hole and the galaxy by
Another
a factor of
intriguing
50.
discovery came from the detection
This
of a
allowed the
repeating
U.S. to
signal from a
capture the
dwarf
image and
galaxy
the
3
spectrum of the
billion
black
light-years
hole
away.
and the galaxy with
Researchers at
unprecedented
Nanjing
clarity and
University in
detail.
China identified the
By
signal as
analyzing the
originating
image
from a
and the
dead pulsar
spectrum, Webb
interacting
was
with
able
an
to measure the
asteroid belt,
mass and the
creating
accretion
signals
rate of the
observed
black
by our
hole,
radio
as well as the
telescopes.
distance and the age of the
This
black
finding
hole and the
underscores the
galaxy.
complexity of interpreting
The
cosmic
mass of the
signals
black
and
hole
highlights
is
the need for
1.6
continued
million times
exploration
that of
and
our Sun,
analysis.
and the accretion
In
rate is
summary,
very
the
high,
22-minute
about
repeating
10% of the
signal
Eddington
remains
limit.
one of the most enigmatic
This
and
rate is
intriguing
so high
discoveries in
that the
modern
black
astronomy.
hole is consuming more
Its
than
origin,
100 solar masses of
whether
gas and
natural
dust
or
per year,
artificial,
eating its
continues
host
to elude
galaxy to
scientists,
death.
prompting
The
ongoing
distance
research and
and the
debate.
age of the black hole
The
and the
search for
galaxy
answers
are
involves a
determined by measuring the
multidisciplinary
redshift of
approach,
the light,
combining
as
astronomy,
explained before.
astrophysics, and even
So,
considerations
both
of
objects
extraterrestrial
combined are the most
intelligence.
distant and the
The
oldest ever
resolution of this
observed,
mystery
dating
could
from
potentially
400
reshape
million
our
years after
understanding
the
of
Big
cosmic
Bang,
phenomena
more
and
than
the
13
universe's
billion
underlying
years ago.
mechanisms.
What